All right, last one for 6.1. This is a culmination of everything you've done up to this point in chapter 6 or in 6.1. We're going to factor each of the polynomials by grouping. If it's not factorable, we have to say that it's not. So the trick here is, if it doesn't work one way, flip the two inside terms and retry. If it still doesn't work, it's not factorable. Just keep that in mind. I'll remind you later on. So to start the process, grab the first two terms, grab the second two terms with the sign. This is going to play a very important role in the next example. So include the sign, put a plus between them. I tend to rewrite this because I don't like it crammed all together. AX plus AY. All right, so now I go through and I say, okay, well, I need to find out what's in common with 3x and 3y, and only in this pairing am I going to pull out the greatest common factor. So I'm basically going back to what we did in the second video. I got to find the greatest common factor of these and pull it out. That is 3, so I'm going to pull out a 3. If I divide each of these by 3, so 3 divided by 3 is 1, I'm left with x. 3 divided by 3 is 1, I'm left with y. Plus, I have ax and ay. I have a in common with both, so I can pull an a out, and then I have x plus y. Because, again, a divided by a is just going to leave me with x. A divided by a will leave me just y. So, again, I go back to that question I asked in the previous section. I said, okay, look at the stuff in the parentheses. Are they identical in every way? Yes. In that case, then that's one of them. And the stuff that's left to include the sign is the other one. Now, at this point, I get several questions typically. And the first question is like, well, wait, I put a plus 3. That's fine. That's perfectly fine. It's not going to hurt anything. And then later on, I'll get the question like, well, what if I had 3 plus a first, and then I got x plus y? Now, it's still multiplication. You can flip the two. It's okay. That's fine. The order doesn't matter. The order matters only when it's subtraction. Then the order matters. So, because these are both addition and we're working in multiplication, you can flip stuff around all you want. It's fine. All right, this next one. Again, we're going to walk through the same exact process. Be very cautious on the signs. This is where people get in trouble. So gather up the first two. Gather up the next two to include that sign. Get the negative sign in there. Please get the negative sign in there. Put a plus in between. I'm going to rewrite. xy plus x plus negative y minus 1. Now, this is going to also give you an example of why do we pull out a negative when it's a lead coefficient, because it's going to make your life a lot easier here. Mostly because it'll make it happen rather than just leave it alone. X and x both have a common factor of x only. If I bring out an x, I'm left with y. X divided by itself is 1. You always end up with the same number of terms. Another common mistake. People are just like, oh, it's just y. Well, how do you get the other x in there? Plus. Oh, let me switch gears here. I have a negative as the lead coefficient. I'm going to pull out a negative 1 then. If I had negative 2 and negative 2, I would have pulled out a negative 2. So I'll pull out the negative, and then I'll decide, are there any other common factors? There aren't. So a negative divided by a negative is a positive. Negative 1 divided by negative 1 is a positive 1. So we go back through our checklist. Well, red. Are the two things inside the parentheses identical in every way? Yes. All right, then that's one of them. The other one is the stuff that's left over. So x minus 1. Now, in this particular example, the x and minus 1 cannot be flip-flopped. You can't go 1 minus x. It's not the same. So if you don't like, if you don't believe me, then just throw it like a 3 in for x and see if you get 3 minus 1 and 1 minus 3 being the same thing. So just if you reverse these two and it's x plus 1 times y, or x minus 1 times y plus 1, that's okay. It's multiplication. You can reverse the two. All right. Okay, so here we go. Last one. Gather with sign, plus. Notice consistency here. Rewrite. You don't have to rewrite it if you don't want to. I just do because I don't like it all squished together. And it helps me see a little bit easier. Okay. So, I look inside here and I say, okay, well, what's my... I'm going to have to scroll down, by the way. But what's my greatest common factor? It looks like a y. 7 and 3 are both prime. They don't share a common factor other than 1. This is going to give me 7x minus 3 plus. X squared and x share common x, and then I have a 2x minus 3 left over. Well, the stuff inside is not the same. Okay, well, scratch that then. We're going to have to do it a different way. So now, what I'm going to do is I'm going to interchange this term and this term. And I'm going to see if that helps. Sometimes it does, most of the time it doesn't. So I'm going to do it over here on the left-hand side. So we're going to have 7xy plus, because that's a 2x squared, it's positive, so we keep the plus, plus. Now the negative 3y had a negative, so it's negative 3y minus 3x. All right, well, pull out the greatest common factor here. That's going to be an x is in common with both, so it's going to be x out front, and then I get 7y plus 2, and I took out an x, so there's only one x left. Plus. Negative 3 is in common with both, so I pull out a negative 3. Negative 3 divided by itself is just a positive 1, so I get y plus x. Again, not the same. Since they're not the same, this is not factorable. Try it both ways. Sometimes it happens that it's factorable one way but not the other. But if it fails both ways, it's not factorable. Now, this particular test for unfactorability, if you want to call it that, it's going to change ever so slightly when we hit 6.2 and 6.3 and 6.4. 6.5 is just a 6.1 through 6.4 review and mangled up. But when we hit the trinomials and we're using this particular method to factor them, in order to be not factorable that way, you cannot have a common factor at all. So it cannot, the second step through the fourth step can't function. If they do, if any of them do, then it's factorable. So, all right, that ends 6.1. Take a look at it. There's a lot going on there. Practice, 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 practice. All right. If you have any questions, let me know. I'll make a video for you. Or we can just jump onto Zoom. Take care.